So do you think you can write an equation for each of these companies?
Yes, I think I can. Do I have to write out all the zeros?
Okay. All right. So I've noticed that you have no equal signs there. So
Yes.
instead of write an equation, is there any way to write that with an equal sign, each of those expressions with an equal sign?
Well, it's just what you're trying to find. So, like, it could equal number of visitors.
Okay.
That's after how many years, which is X.
Okay, so how would you represent the number of visitors?
Represent it.
In other words, what would you use to represent it?
I could use another variable.
Okay.
That's
All right, awesome. So you get
and
2 million plus 13x equals y,
13.
and that's for which
That's
company?
supposed to be 13 million. Just do,
Do you want to change it?
yeah, I'll change
Okay.
that.
And then you get 17 million. So that's the look at me. And then 17 million minus 2 million x equals y. Okay. So those are your two equations. So now you have part B, make a table of values for 5 years for each of the companies. So you'll notice that the chart is set up. Like this. So you have one over there, one over there.
Okay, so. And is it okay if I just use like 2010? Any
Do
year I want?
whatever you think is the right way to do it. Yeah. All right. So what are you running into for an issue right now?
I'm just figuring out. So that's times 1 year, so it's 2 million plus 13 million.
Okay.
15 million.
So what did you plug in there for the x value?
I plugged in 1 year because it was 1 year after 2009,
Gotcha,
and
okay.
that was the start.
Right on. Thanks.
And then so that's times 2.
Do you want to calculate it?
It's, am I allowed to use a calculator? Well, I don't need
You can
a
if you,
calculator for
okay.
that
All
one.
right.
Let me see. 28.
Where did you come up with 28?
I did 13 million times 2,
Mhm.
which is how many years after
Mhm.
2009.
Mhm.
And I got 26 million,
Mhm.
and then I did plus 2 million.
Gotcha. Okay.
And then, so 13 million times 3 just is 39 million, but then plus 2 million is 41 million. And then that is times 4, so that's so am I allowed to use a calculator?
Yeah.
I can do that. Okay, so I got 52 million from that, and plus 2 million is 54. So 13 million times 5 is 65 million plus 2 million is 67 million.
Okay, so if you look at these numbers right here,
Yeah.
is there a relationship between those numbers going down that line?
It is. There probably is. I just can't see it.
Okay, so to get from 15 million to 28 million, how much of a jump is that?
So that's 13 million.
Okay, to get from 28 million to 41 million, how much of a jump is that?
Yeah, 15 million. Or
Try
to,
again.
to 13 million.
Okay, and then to get from 41 to 54 million,
13 million.
and then from 54 to 67.
13 million.
So where do you think that 13 million is coming from?
The rising number.
Okay, all right. So do you want to do buy your stuff?
Sure.
Not buy yourself.
Alright, so I got 45 million for the first one.
Okay.
Because it's 1 year, only 1 year.
Okay, and then how did you get 45 million?
So 1 year, that's the X,
Mm-hmm.
times 2 million is 2 million.
Okay.
47 million minus 2 million is 45 million.
Okay.
And then,
How did you get that number
I
so quickly?
did, well, I realized from the last one
Mm-hmm.
that it's probably gonna either decrease since it's a minus,
Mhm.
but in the last one it increased by
Good.
13 million each year.
Mm-hmm.
So I did 45 million minus 2 million
Mm-hmm.
because so
Okay, so if you plug the 2 in for X, you would get 4 million, and then
47 million minus.
It works. Yeah, so your method works.
Yeah, so 41 million for this one.
Okay.
And 39 million for this one. And 37 million for this one. Because each time it goes down 2 million.
Okay.
Because it decreases each year by 2 million.
Okay, so you're going to take the data that you got from the table, and you're going to graph each equation. So when you're graphing each of the points, can you make a circle on the points
Yeah.
for the, look at me, and the X's as your points for buy your stuff?
It's just kind of a small graph.
Okay, so since it's a small graph, what could you do?
I could make they're called intervals,
Mm-hmm.
a lot bigger.
Okay. All right.
So am I graphing both of them on the same graph?
Same graph, yeah. So you'll make, instead of making dots for this one, you'll just write circles, and this one you'll use X's as your points.
Okay. So am I allowed to do one of these things where I like skip?
Sure, if you want to, if that's what you want to do.
Okay.
Absolutely.
So start off with 0, 0, and for the X. Oh, I don't. And do you want years on the X, or does it years on the X and visitors on the Y?
You tell me which one you think is right.
Okay. I'm gonna put years on the X.
Okay.
So
So what year would be year 0 there?
probably 2009.
Okay.
So I'm gonna start
Hope that's fine.
2009.
If you did 0, 1, 2, 3, 4, 5, that'd be fine. You just have to label this axis years since 2009 if you wanted to, right?
Okay.
Or you could do it 2009, 2010, absolutely.
Alright, that would be better, I think. So, 0, 1, 2, 3, 4, 5 years. And then in 2009 they had 13 million, 47 million. So that's country. But I'm just gonna say this is 10 million. And it goes up to 67.
So do you need to put all the zeros in each one of these? Do you think?
Oh no, just
Could you just label the axis differently?
yeah. I could
Okay.
label it like in million.
Yep,
So,
great.
actually, I think I need that needs to be bigger. So, but it needs to be lower than.
Why does it need to be lower than 15?
It starts out at 13 million. So
Which one? Would you see 13 million?
the year 2009
Okay.
for Look at Me.
Okay.
So it's at 13.
So was your 10 initially, your 10 a good guess?
Yeah, but then if you go 20, 30, 40, 50, 60, it goes up to 67 in 2014.
Mhm.
I would not be able to graph that.
Okay.
So I'm gonna try.
So could you pick different intervals even though you started at 10?
What do you mean by that?
Do you have to go by 5s or 10s? Could you pick a different interval for each one of these? Could these be 7s or 8s?
Yeah.
You can do it however you want. Go ahead.
I'm just gonna. I'm just gonna go 10, and then I can go 25, and then 40, 55, 70.
Sure.
I don't really need to go any higher, but 85.
Good.
So, with 1 year, so I need to graph 0, so that is, it's at like 13 million.
Okay.
So, did you want me to do like different points?
Yeah, circles for this first one.
Okay. So I'd say it's maybe like around there.
Okay.
And for 1 year since, which is 2010, say it's 15. So it's about there.
Okay.
28. 2 years since, it's 28, so I'd say it's around there. 41 is, for 3 years, is about there. 54, that's about there. 5 years, 67.
So do it the best way you know how.
Okay, I'm just gonna rewrite it just for
Okay.
so I can see. That's 2x plus 47. And I'm gonna try to get rid of the x on the side by adding 2x
Okay.
to both sides. And I get 15x plus 2 equals 47.
Mm.
And from there I got 15x plus 2 equals 47. And I'm gonna try to get them on. I'm gonna try to get them on opposite the x and the regular on the opposite sides. So I'm gonna minus 2x from both sides. so I'm dividing both by 15.
Okay.
And that's going to get me x equals 3.
Okay. All right. So how do you know that that's right?
I can check to see if it's right
Okay.
by plugging in x.
Okay.
Would you like me to do that?
Yeah. You can just talk me through it. If
Oh,
you want.
okay, yeah. So I plug in 3 to the. We got plug in x equals 3, so I plug in 3 to this x and 3 to this x.
Mhm.
So negative 2 times 3 is negative 6 plus 47 is 41.
Mhm.
So 41 on this side, and then 3 times 13x is 39. 39 plus 2 is 41. So 41 on this side is equal to 41.
Okay. So now you're going to look at the two problems that you just did. Compare problem on page 1 and problem on page 2. How does the equation on page 2 compare with the equations in problem A on page 1? So look at those two problems side by side and tell me how they compare to each other, page 1 and page 2.
So instead of you can flip flop these around. 47. I think it's the I don't know. It's a property. So you can flip flop that. 47 minus 2x is the same thing as negative 2x plus 47.
To me, do it properly.
And that is like the same thing if you just block out these, like the millions.
Okay.
And so it's 47 minus 2x.
Okay.
And then,
So in a similar way that you've knocked off the zeros here,
yeah.
you knocked off the zeros up here.
And it's
Okay.
the same thing for this side. If you knock off the zeros
Mhm.
and just put like a million, it's 13x plus 2.
Awesome. Okay, now what do you think this, having set those two equations to each other, because here there were two separate equations.
Yeah.
Now they're in the same equation, but just pieces of them. What's missing from those, from this? What do we get rid of in these two equations to create this? What letter?
Y.
Okay. So keeping that in mind, we set the y, what the y's equal to each other, right?
Yeah.
What do you think this number represents compared to this graph? The x of 3. Where did that x of 3 come from? Looking at that graph.
It's year cents.
Okay.
Maybe year cents when they're equal to each other.
What's equal to each other?
The number of visitors are equal to each other.
Okay, and what are the number of visitors? What letter was represented by the number of visitors?
Y.
Okay, so when the y's are equal, that's how you get the solution.
Yeah.
Fair enough?
Yeah.
Okay. I'm not going to make you write all that stuff down. Right. Now. Oh. Okay. Okay, now you're keeping that in mind. I want you to take this down here, just like you did up here, and you're going to go step by step. Now in each of these steps, each one of these steps, you're going to create new y equals equations the same way you just did from here to here. All right? So take your first step from here,
Yeah.
when you added 2 to both sides,
Okay.
and write it right underneath here. Do that first step right here. So yeah, so you're doing what you did right here in this one.
Okay. So.
Try to do it on the left side because I don't think I gave you enough graphing area.
Alright, so I'm adding.
So rewrite this whole thing. Just rewrite this. Forget about these two things. I'm going to refer back to them later.
Okay. 13x plus 2 equals and then so I'm.
Did you add 2x?
I added 2x
Yeah.
on both sides.
Oops.
2x plus 2x that equals 15x plus 2 equals 47.
Okay, now from this new equation, in the same way that you split this one up into two y equals equations, where the left side was written over here and the right side was over here as y equals, do the same thing with this equation. So you're going to get y equals, what is the left side?
For the left side is y equals 15x plus 2.
Yeah, and what would the right side be?
Y equals 47.
Okay. So, all right. So what you're going to do now is you're going to take that equation on the left side
Yes.
and graph it as a line, and then the equation on the right and graph that as a line as well.
Okay, so the equation on the left, this is the slope, like
Mhm.
rise over run.
Mm-hmm.
So, and you are starting at 2,
Okay.
because that is the y-intercept.
Mm-hmm.
So that's where the line
Alright.
crosses the y.
Can you go ahead and graph that, what you just said?
So
You can make X's or squares or whatever you want to do.
it starts at 2,
Okay.
and you go up 15. So it'll be at 17.
Yep.
And then you go over 1.
Okay. So go ahead and put a square or dot, whatever you want to do there. Okay. And what would the next point be?
It's probably up 15.
Okay.
Should be 32.
Mm-hmm.
And that would be right there. And then you go over 1.
Okay. What would the next point be?
Up 15, which should be 34. I mean, 40. 44. No.
So you're at 32 and you're going to add 15. Do you want to do that?
47.
Okay.
So it's just 2, and then I think this is
Okay. And then one more time.
47. 63.
So you're at 47 and you're going to add 15.
Yeah,
You could be at 62, wouldn't you?
62.
All right.
Next thing would be 70.
Yeah, I mean you can stop there because you'll run off the graph there, which
Yeah.
is fine. So go ahead and draw that line. Okay. Carry it right through to the end of the graph if you could, H. Okay. And now the next one, y equals 47. Can you graph that one? Maybe just use open circles for this one
Okay.
if you need to.
So the
So do you have a slope there?
I have the y-intercept.
Okay.
That's the only thing I have.
Okay. So where's
First point is here.
okay. Now what type of line does y equals 47 create?
A straight line across.
Okay, so a horizontal line
Yeah, horizontal. Yeah.
right through 47. Okay. All right. Now what I want you to do,
Yeah.
is just make a dotted line. Find the put your pencil on the intersection point of those two lines. Okay. Now draw a dotted line straight down. Okay. What do you notice about the two sets of graphs, the one that I did and the one that you did in this dotted line? What's the relationship between those two?
All 3 lines intersect at.
What's the common number there?
The common number is.
Try to focus on the dotted line if you can.
This, the common number is 3.
Okay.
3 intersects.
Where else have you seen 3?
And what the x equals.
Okay, so the x equals 3 on this page too, right?
Yeah.
Okay. All right, now go ahead and turn the page over here. I'll turn it for you. All right, now what's step 2? So now you have these equations right here. Oops, sorry. this equation right here.
Okay.
So rewrite that equation on step 2. Okay, now go ahead and do your next step. What was your next step?
My next step was subtracting two from each side.
Okay.
2. So I got 15x equals 45.
Okay, now set up a y equals equation for both the left side and the right side.
So y equals 15x.
Don't forget your x there.
Oh.
Yep, that's right.
Y equals 45.
Okay. All right, now graph on this thing again, those two equations. So y equals 15x and y equals 45.
So the rise is 15 over 1, and it must start at 0.
Okay.
So plus 0.
Great.
So you could add on plus 0 and it'd be amazing. Y-intercept is 0, and you plus 15 go over 1.
Okay.
And so
You can just like you can use the x, a triangle, whatever you want to do to.
yeah. Triangle.
Okay.
And you're just gonna go 15 up, 15 over.
Okay.
So I just know that's gonna be
Great.
straight line there.
Okay.
It's kind of hard to.
Great. Okay. So
The next
yeah,
one
you can
is-
do actually that one will fit, won't it? Right, go ahead and draw that line best that you can. Yeah, they're getting a little tight there. Okay. And now do y equals 45.
Okay. Y equals 45 means the y-intercept is 45.
Mm-hmm.
And so there is a horizontal line
Okay.
straight across.
Okay. Now put your point on the point of intersection again
Point of intersection
of those two
these
lines that
two
you just
lines.
did. Yep.
I think it is there.
Okay. And then draw a dotted line straight now.
There already is one.
What is it?
It's goes to 3.
Goes to 3 again, right?
Yes.
Okay. Do your step 3 down here.
It's 3 from this. Yeah.
Yep. So you can take that. Yep.
15x equals 45
Yep.
divided by 15 divided by 15 to get just x.
Okay.
And then you get x equals 3.
Okay. All right. Now make your left and right equations again. So your left side would be.
Y equals x
Mhm.
and y equals 3.
Okay. So go ahead and graph those two equations. Y equals x and then y equals 3.
Alright, x.
So maybe-
I believe, thinking of two things, y equals x is just a straight line, like here, but I'm also, like from this point, that point, that point. But I'm also thinking, because I'm thinking of like, when you reflect a lot, when you reflect something over y equals x,
Oh, very good. Okay.
but also that you could put like 1 over 1
Awesome. Yep.
in front of that.
Yep. So your slope is 1 over 1.
Yeah.
Yep. Good.
So,
And you're starting at 0 is what you said before, right?
Yeah, because there's no, the y-intercept is plus 0.
Yep.
So,
Great.
So it's like 1's right there, go over here,
Mm-hmm.
and I'll do a
You can make x's if you want.
x, and then I'm going up 1, so that'd be 2 over 1. So 2, 2 is the point. 2, 2 is the point.
Okay.
Then 3, 3 is the point.
Okay.
4, 4 is the point. And 5, 5 is the point.
Right.
Next point.
Awesome. Okay. Now graph y equals 3.
Intercept is 3. So you
Okay, put your
Kind of hard to see.
it's okay. Put your
Yeah.
pencil on the point of intersection.
Right there.
So what did you notice about each one of those equations?
They all intersected at 3 years since.
They all intersected at x equals 3.
Yeah.
So the x equals 3 was your solution, and all of the lines for each of those equations, each step in the equation, intersected at x equals 3. Very good. All right, H. Why do you think that dotted line, every point of intersection, always had a dotted line that wound up at 3 on the x-axis?
Because in my solution, x always equaled 3,
Mm-hmm.
and in every single step, it's always going to equal 3.
Okay.
And no matter what.